All right, this is pre-calculus video on squaring a binomial. All right, you're going to use this formula right here. I'm kind of throwing in this topic. This is a multiplication or product rule in the middle of a factoring unit. There's a method to my madness. This is a formula that is not necessarily stressed in Algebra 1, but it is really important. We're going to use this a lot this year. So you have to be able to use this formula. And in the next video after this, we're going to be doing the opposite of this. We're going to use the formula backwards. So here we go. If you know this formula, you can you can skip the step where you rewrite this as two separate binomials and then FOIL them, okay? So I don't have to go through the 3 steps that would take. I'm going to use this formula for a shortcut. I am going to square the first term, take the 2 terms, x and 3, multiply them together and double it. Okay, that's this part of the formula here. So x times 3 times 2 is 6x. And then the last term squared, so that's 3 squared, is 9. Okay? That's it. All right, then you don't have to go through the FOIL and the combining of like terms if you have this formula memorized. All right, now, problem 2 is the fraction, so you're already scared, I know. So the first term squared is x squared. For the middle term, I'm going to multiply them together and double it. So I've got x times negative 1/2 is negative 1/2 x. Well, what's negative 1/2 doubled? Negative 1/2 doubled is 1. So the middle term is negative 1x. And then the last term squared, okay, you square both top and bottom. So 1 squared is 1 and 2 squared is 4. Right. Problem 3. A squared, that's 2x squared, gives me 4x squared. First term squared. Multiply the 2 terms together and then double it. So 2x times negative 3 is negative 6x. Doubled is negative 12x. Negative 3 squared is positive 9. Okay, problem 4. X squared squared is x to the 4th. Multiply the 2 terms together and double it is 6x squared, and 3 squared is positive 9. All right, so that's it for squaring a binomial.